Hello guys, this is Doctorbass, and here's some SUR RON motor porn for you guys. So that's a completely disassembled motor, and there's a reason for that, because I will make some improvement on this one. So this motor is likely brand new from this very recent SUR RON. That one is only 87 kilometers. So yeah, likely less than 100 kilometers on the Odo. So yeah, all right. So the reason I disassembled this motor is first because I find it ridiculous to extend those wires with a bolt and contact resistance and adding some problems over the times. Yeah, well, I know a lot of you guys already have this back 8000 upgrade with the extension wires, but I'm not a big fan of that. I've been in e-bike construction since more than 12 years now, and after modifying a lot of hub motors, high power full setup e-bike and these things, including modify motor, I find that it's time for an upgrade on this one before it even have 100 kilometer range on it. So there's some things that I wanted to point out about the construction of that motor. Okay, so first of all, this is very nice to have some seals here for the bearings here, but and you see this motor is brand new and there's already rust here just because of the moisture, and it has less than 100 kilometer live distance. So let me show you something. That is a zero motor, and that is a SUR RON motor and a zero controller. You see from my hand big power here, but no worry, those will not go on this one unless I go crazy mad Max bike. Anyway, so this motor here, that one, if I open it, you will find a lot of rust on it. The stator and the rotor lamination all rusted, and even the oil sensor here pretty affected by that because there's a lot of corrosion. So that motor maybe had some rain, or maybe just after pressure washing. A lot of times water get inside because of the suction effect. When the motor is hot and it cool down, there's a variation of pressure between the outside and the inside, and all the possible input where the water can get in, water will get in. So you see, so that's why I want to prevent that. And on all my hub motor, I'm using this spray-on varnish, which is especially made for electric motor, and I will spray that stuff on all the exposed part of the rotor, including the lamination. Everything will be covered. Okay, there's a reason for that. I don't want to have some rust here. I don't want to have some rust dust that will end out on the winding, making some short. Sometime I already saw that. A hot spot on the motor are created by some short of the iron dust here. I want to avoid that. And by the way, you see, it's like they named the poles of that motor. You see, that's not me. It's made by the factory. So you see the cables extension. Those are 6 gauge wires. Okay, it's a lot. It's great, but for up to 500, 600, or even 800 phase amp, I know there's saturation of that motor. I'm not sure what's the phase amp maximum you can put in before saturation. We will test that, and it's quite easy. But the modification I want to do is to add some 4 gauge on these. Those like seal can take that. So instead of extending those stock wires to reach the back 8000 controller, I will use some of these quality welding cables through 4 gauge with through copper inside, and I will just remove that one, and I will get all the strands, add a copper sleeve, and solder everything, crimp everything, and make those longer wire for the 4 gauge. And then another very interesting part is the rotor. So you see that rotor, the way the magnets are stick on is two way. First with those screw here, and second by the trapezoidal shape here relative to the radius axis. At first I thought that those little slot here were straight with the radius, so they were parallel for each magnet, so each magnet can come off the rotor. But there's a trapezoidal shape. That's interesting. That means that the magnet cannot escape this way unless it break in two parts. Okay. We saw someone having the rotor magnet fly apart because of high speed RPM, like 4K RPM, 14K RPM, and that's normal. The centrifugal force on these is extreme at those speeds. That's why most of these motor, including the zero motor, never go over like 6,000 RPM, and for many other reasons. But on this one, something interesting I saw is that there's a very interesting gap between the stator and the rotor. Okay, so there's a lot of gap, I think, to add carbon wrap. And carbon wrap is a new technique for reinforcing the rotor against the centrifugal force. And even Tesla, for the plate model, the Tesla Model S plate, are using carbon wrap around the copper rotor. That's not the same type of motor, it's an induction motor. But to avoid the copper to break off, they use carbon wrap. It's a tightened carbon that's wrapped around, and then they add some resin or something like that, high temperature. And the rotor from the Tesla, which is larger, can go up to 20,000 RPM. That's a lot. That motor will not go that speed, and I'm not sure if I can get carbon wrap around this. But at least the first thing I will do is disassemble all these magnets, name them, and have a repair for these, you know, location. And then I will add some Loctite 683 or 638, not sure. That's a bearing compound. That is actually an excellent adhesive for high temperature too. It's like 4,000 or 5,000 psi at ambient temperature, and like close to 1,000 psi of pulling force, or shear force instead, not pulling but shear force, that this adhesive that you can put on the rotor and then put back the magnet and tighten it. So the magnet will be not just mechanically by the screw fixed on the core of the rotor, but also with a very powerful adhesive, and that will prevent the magnet from flying apart. And I think that's an option that I will do, but for now I will not do that because I don't have this 683 or 638 Loctite bearing compound, but I will order some and get some soon. So that will be the next upgrade. The bearing are already sealed, so that's good, and not a lot of loose here. And something you want to pay attention if you disassemble this motor, guys, is this magnet. Okay, don't push on it, don't stress it, because that's the reference for the Hall sensor. That's, oh sorry, yeah, the Hall sensor disc here. That's you know, around this kind of a plastic here, there's Hall sensors, and they detect the position of this magnet and tell the controller which phase and which synchronous signal to send back to the phases. So you don't want to stress that magnet when disassemble it. And even if you replace the bearing, pay attention to the location and the clocking of this one. Okay. All right. So thanks for watching, guys. I will make the upgrade and post a new video soon. I hope you enjoyed. And if you want to have more information, see my YouTube channel, Doctorbass. There's a lot of electric stuff, interesting stuff, drag racing, electric motorcycles, and these things. So thanks for watching. Bye-bye.